Hello students, welcome back. In this video, we're going to add a pressure system to Broshi. This is going to come in the form of what we'll call blockers. A blocker is going to be a special type of block. It'll be like a stone-looking block that when it lands, it's going to prevent us from clearing anything underneath it. A blocker, no matter what lands on it, will never get canceled. So anything underneath it will remain in our game for the rest of the game. So let's head to the computer screen and let's dive right into this pressure system of blockers. So I have lesson 6's starter file open here in vscode.dev. I'm going to minimize this file though because we are going to open our file directly in the browser. So go to our Broshi folder, lesson 6, and we'll open lesson 6's starter file. So here we have our current state of the game. Nothing new. Basically everything that we had previously with our ramp, our block, we're switched to a time-based system, but no blockers are going to show up because that system is not yet implemented. So let's come back over here and let's look at mission number 1 in our mission checklist. It says set the blocker spawn chance constant. All right, so right now, if we look, we have a 75% chance to spawn a blocker. That seems pretty unfair. I don't want to have a 75% chance to spawn something that is just going to really throw off my game. So here, we're going to change this, and let's lower it to be, I don't know, maybe like a 15% chance. So we're going to express that as a decimal. 0.15 would be 15%. So that's pretty good. 15% chance to spawn a blocker, which leaves us an 85% chance to spawn a random colored block. So I like those sort of odds. All right, and while we're here, let's look and see what else we got. It looks like we've got a mission here in our student edit zone for something called a soft drop multiplier. We'll have to take a look at that when it comes to mission number 5. But right now, we got our blocker spawn chance set to 0.15. Any new colors? Ooh, we have a blocker color, which is 8E, 8E, 8E. I bet that's going to be some kind of like grayish color. Let's see, what else do we have? Any new gameplay variables? No new gameplay variables. All right, so with that, let's go look at mission number 2. Mission number 2 finds us in generate block data. So a blocker is just going to be a block. It's just another block, just like our colored blocks, except we are going to set the type to be a different value. See, for a colored block, the type is color, and then we randomly selected our color from our array of colors that had like our red color, our green color, our blue, or red, yellow, blue, and purple colors. But now we are randomly creating a number. See, we got this variable here called roll, and when you call random, it's going to give you some number between 0.00 to 1.00. So maybe, I don't know, maybe it was 0.09. And if it's 0.09, then we are going to take the type and the color of the block that we are about to generate, and we are going to change it. We are going to make this block one of our blockers because our blocker has a 0.15% chance, a 0.15 or a 15% chance of being created. And since 0.09 is less than 0.15, we will create it. See, if we had generated a random number and it was 0.16, 0.16 is greater than 0.15, we'll just keep our block a colored block. So this is how we can use our percentage. So let's actually ask a question here. We'll say if, all right, if, and then we'll look to see if roll is less than the blocker spawn chance. Second one right there. If that is the case, then what do we want to do? Well, we're going to open up curly brackets because we are going to run a couple of lines of code here. We're going to take the type of the block that we're going to generate, and we're going to say, nope, it is not going to be a color block. We are going to say, hey, let's set type equal to blocker. We're going to make a blocker. And then we're going to change its color. We're not going to randomly choose from red, purple, blue, or yellow. Instead, we'll set our color to the blocker color constant from our color palette. And then when we create the data structure that represents our given block that we generated, whether it is a color block or a blocker block, the type and the color are going to change appropriately. So this is going to work out really nice. And the type is going to help us determine whether or not these blocks should be cleared or stay forever and ever and ever, right? If the type is a color type, it should be cleared. And if it's a blocker type, it's going to stay forever and ever and ever. So let's go look at Well, let's run this. Let's just see. Is anything going to happen? Let's see. Do we get any blockers? So we're going to have to run this for a little bit as our objects fall. Maybe I can pause the video and see if any blockers begin to show up. So I'm going to pause it. I'm going to let it run for, I don't know, maybe like a minute. All right, so I just let it run for a minute, and if you look, I have some blockers, okay? Whoa, but wait a minute. That blocker landed, and it cleared what was underneath it. That doesn't seem right. But the blocker is present. The blocker is there, but something was not quite right there. Whoa, and did you see that? Those got cleared. That was not right either. So we have some whack. Whoa, and those got cleared. So the blockers are present, but we're getting some weird clearing behavior now that we have blockers in place. So let's go see what maybe mission 3 has us working on. So I'll type mission 3 up here in my search bar, and mission 3 finds us in the resolve block landing function. All right, so remember here, we figured out what column our block is. We take in a block that we're going to resolve its landing, and we figure out the number of blocks that are in that column. We get the top block. So now I have the top block, and now we're going to look at our blocker clear rules. We're going to prevent blockers from clearing with color matches. So only allow clears when both blocks are color blocks. Okay, so here it says const color match, true. Const both are color blocks, true. That doesn't seem right. I feel like colors match. That should be like asking a question like, do the colors of our blocks match? And maybe that's why, like, are these going to clear? Yeah, do you see? As soon as they stack up, right, we resolve that landing, and we are just saying, hey, true, the colors match. That is not right. So we got to actually figure out, do the colors match of our top block and the block that is falling? So here's our top block. It's called top block, and we're going to get its color property. And we're going to check to see if it is equal to 3 equal signs, the block that is falling, its color property. So now we have the colors match, true or false. And then next we're going to look, both are color blocks. Well, this is set to true. That might not be the case because one of our blocks could be a blocker block. So we're going to look at the top block's type property, and we're going to see if it is equal to color. And we're going to see, is the current block that's falling, is its type property equal to color? In order for that to happen, right, if colors match and if both blocks are color blocks, then when they land, we will clear them. Because if one of them is a blocker, then we will prevent this from happening. We will prevent the removal or the popping of that block from the column, and will prevent our score. Because that's what blockers do. Blockers block that functionality. All right, so now if we stack things up, we should hopefully not see things getting cleared unless they are the exact same color and they are both colored blocks. All right, let's see. Let that thing fall. Perfect. Oh, well, we got 2 yellows, so I can't test this here right now because they will just clear. So let's see if we get a new color. All right, so blue. Let's see if this works. This will not clear. Hopefully, this will not clear. All right, and it didn't clear, so that's perfect. So let's put a blocker down now. So a blocker should not clear it. All right, very good. And a blocker should not clear with another blocker, so because they're not color blocks. They're perfect, so that didn't work. And then let's see, what else can we test? I would love to see if we get like another blue or another yellow. Okay, so let's put that right there. Will that yellow clear, or will the blocker prevent it? Hey, look at that. The blocker prevents it. So now I can't clear that. So these blockers are working great. So let's see what is next here. So that was mission 3. Let's go to mission 4. Mission 4 says danger row failure. End the game when a column reaches our danger row. Trigger the lose state when the stacks fill the grid. All right. So when the blocks reach this row, it is essentially going to be game over. So this is like our spawning row. So right now, you remember in our last video, the blocks just kept going up and up and up. Well, now this is our pressure system. We got to exert some pressure. And one way we exert pressure is by losing the game. And so if you look here, we ask a question. It says, if false. Well, you know, false is always going to answer no. It's always going to answer false. So this line will never run. We never trigger our game over, where current game mode is equal to game mode.lose. So what we're going to do is we are going to check when we resolve a block landing, meaning a block just landed somewhere, we're going to check that specific column and we're going to see how many blocks are in that column. The way we check a specific column here is we go to our array, our container holding every single column in the game. It is called columns. I'm going to open it up and I'm going to grab what is ever at our col index. Right here, column is the column number that our current block is. Is it column 0, column 1, column 2, column 3, column 4, or column 5? Column 0, column 1, column 2, column 3, column 4, or column 5. And that column is another array, right? That column is an array. And arrays have a length property, which is the measure of how many things are inside of it. So that's how many blocks are in the array. So let's pause for a second and let's think about how we're going to check to see if it should be a game over. Well, let's count how many possible blocks we could have. We can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And if we add the 13th block, then we've been put up here in this row. It should be a game over. And that row is our row count. We've got 13 rows, right? So we've got, we can start counting them here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 rows. And that is our row count variable. So if the length of our array, which is a representation of how many blocks are currently in that column, if it is greater than or equal to row count, then it is time to end the game. So now we have an actual game over condition. Let's check it out. So I'm going to pause the video. I'll build up a really high row and we'll see this in action. Okay, so I've got a row that's getting, or a column that's getting pretty high. Let's see if we can reach that final. Oh, I don't want to pick that one up. Oh, I can't switch there. Bummer. It was too high. Let's see. Nope, I don't want to pick that purple one up because that would lower my column. All right, bear with me as we play. Okay, perfect. So there's that. So one more drop, and it should be game over for us as long as we don't pick up a blue one. And right there, perfect. So once that yellow one hit, it triggered our game over warning because the number of blocks there equaled our total number of rows. So press enter, and then we are back to the beginning of our game. So now we got that game over condition in here. Now let's go to mission 5. Mission 5 says, let's add the soft drop multiplier constant. I had to play test that, and I had to sit here and watch this slow block fall. We don't really want that. I want a way to speed up the rate at which the block falls. And we're going to do that by holding the down key, I think, or the S key, and it will speed up the block for us. So we are going to create, we'll call that the soft drop, all right? We're going to speed it up, and we're going to create a multiplier for this. Basically, we're going to control how much faster the block falls when our soft drop key is being held. And so right now it's set to 1, which means we're going to make it fall 1 time as fast. Well, you multiply anything by 1, you're going to get the same value back. So we want to make it bigger. So this would be 2 times as fast, 3 times as fast, 4 times as fast. I'm going to do 5 times as fast as my soft drop multiplier, which makes mission 5 done. All right, that was pretty easy. Mission 5 was pretty easy. But now we got to implement this soft drop. So mission 6 finds us in update blocks. All right, so we set our spawn timer and figure out if we got to spawn blocks. And then we check to see if the block is waiting. So we keep it, right up here so we can kind of make our game plan of where we want to move our columns. And then if the block is falling, it looks like we create a brand new variable called isSoftDropping. And it says detect when the soft drop key is being held. Check for the down arrow or the S key during falling. So right now it's like we're asking a question, is soft dropping? And we're just having it set to false. Well, that's not good because what if I am pressing the down key? What if I am pressing the S key? I want this to be true then. I want to trigger the soft drop. I want to make the block fall faster. So let's put in a check. We're going to say key is down, and then I'll put in the down arrow. I'll do down arrow. So I can press the down arrow or 2 vertical bars, key is down, and then I want the S key. So the S key is going to have a numerical code, and its code is 83. So this variable is either going to be true or false. If I'm pressing the down arrow key or I'm pressing the S key, the answer to this is true, and so our variable will become true here. Awesome. So remember, key is down is going to return true or false whether or not the key is just held down. It's very different than the key pressed, which is going to return whether or not a key was in the act of getting pressed down. So key is down is held down, which is exactly what I want. If I'm holding the down arrow, I want the block to continually moving faster and faster. So now if we look, mission 7 is right below us. It says calculate the fall speed multiplier. Use the soft drop input to choose between normal and boosted speed. All right, so our fall speed multiplier either could be, well, we set it to 5, didn't we? So if we want to, have it fall faster, we're going to take our speed and multiply by 5. But if we don't want to, well, what are we going to multiply by? Well, there's that magical number that never changes the value that you multiply by, and that's 1. So we want to either make this 5 or 1, 5 or 1, 5 or 1. Well, how do we figure that out? Well, we just ask a question. We say, is soft dropping? Remember, we figured it out right here. We know whether or not we're pressing that key. This is either true or false. And we're going to learn something new here that is a really great way to set a value of a variable. We are going to ask this question, and we're going to use a question mark. And that question mark is known as the ternary operator. So we're going to say, hey, let's set the value of this variable, fall speed multiplier. We are going to assign it a result from this question. Is soft dropping? So this is true or false. If it's true, we are going to assign a value to fall speed multiplier of soft drop multiplier. That is our 5. Then we're going to put a colon, because if the answer to this question right here is false or no, we're not holding our soft drop key, then what do we want to assign to fall speed multiplier? We're going to assign 1, because we can multiply 1 by anything and not change its original value. Excellent. So that's some decent little math right there. Not too bad, not too bad. Mission 8 says, well, now it is time to apply that multiplier. So now we want to apply it. So let's apply the fall speed multiplier to the fall timer. Increase block fall speed while the soft drop is active. Okay, so let's see. We've got our block fall timer, and this is DT. So our fall timer, remember we set our fall timer. Let's review this. I think our fall timer is where is it? Is it in update blocks? Well, update blocks, we're decreasing our fall timer, but I want to see where I set it. I got to find this for a second. Okay, so we are in generate block data. When we generate our block data, we set a fall timer based off of this variable called block fall interval seconds. And if you remember, that is a ramp controlled value. You can see it right here. Block fall interval seconds, we're using our difficulty ramp to scale it. It's going to start at 0.65, and by the end of our game, at our maximum difficulty, it's going to be 0.14. So our blocks are going to fall faster and faster and faster. So that means at the start of our game, it's going to take 0.65 seconds for the block to move from here to here, to here, to here, to here, to here. We want to increase that value. And so that's where mission 8 is going to bring us. We're going to target DT, and we're going to multiply by our fall speed multiplier. So that fall timer, which was set to what, 0.65 seconds, we're going to subtract our time interval, but if we're holding the down key or the S key, we're going to subtract that time interval times 5. And so that's going to make us pull more off of that fall timer and causing the block to move faster and faster and faster. So let's check this whole system out now. I think we are done here with all of our lessons, right? We did 8 missions. This is great. We did 8 missions. We implemented a couple of really new things. So let's see. Let's test out the soft drop. I'm going to hold the down key. So here it is not being held, and here it is held. Ooh, I like that. That makes it fall much, much faster. And so now I can earn some points. I can move these around. If I know this is exactly where I want it to be, I can speed up that fall. Perfect. And let's see our blockers come in. All right, our blockers, no problem there. Stack these up. All right, here comes another blocker. Perfect. Okay, blockers do not clear, even though they're the same color, because you need to have both blocks be the color type in order for them to clear. And let's just keep going. All right, I cleared that one. I'll switch those. Perfect. I'm going to purposely lose the game, make sure that our game over is still working. I guess one of the things I should check, can we actually clear something if it has a blocker under it? Yep, good. So we can still clear something even if it has a blocker under it. So that was a good check right there. And we are getting to our game over condition here shortly. Let's see, right here. Nope. Oh, we survived. We would have survived, but I want it to end. I couldn't get there in time. There we go. And there is our game over. So the blocker system's working great. Our soft drop multiplier is working great. Our game over condition is working great. I mean, this is pretty playable. Now, if we play it, you should try playing this, full on. I purposely lost the game, but you'll see as the game scales, closer to that 240-second mark where we hit our maximum difficulty, the game gets pretty challenging. And I think we have to give the player a way to get rid of the blockers, all right? Because once they land, they're sort of there forever right now. And so we're going to give the player the ability to kind of fight back and earn bonus points or extra points in doing so in our next video. So I'll see you then.